Welcome to BioinfoBytes, where we decode bioinformatics. Today, we are diving deep into a task you'll run into all the time: multiple sequence alignment. And we're going to put three of the biggest tools out there, Clustal Omega, Muscle, and T-Coffee, in a head-to-head showdown.
So let's jump right in. You already know that pairwise alignment is perfect when you're comparing just two sequences. But what happens when you're dealing with a whole family of proteins? What if you've got 10, 100, or even 1,000 sequences? How in the world do you find those crucial conserved regions across all of them at once? Well, that is the exact problem that multiple sequence alignment was built to solve.
So how do we make that jump from simple pairs to these really complex multiples? Let's first get a super clear idea of what multiple sequence alignment, or MSA, actually is. At its core, MSA is a method for lining up 3 or more biological sequences. The real trick is how the algorithm cleverly adds gaps to get everything to match up, maximizing the similarity you see in each column. And those conserved columns that light up, they're not just pretty visuals. They often act like giant flashing arrows pointing to the most important functional or structural parts of a protein. This is exactly why MSA is the absolute foundation for things like building phylogenetic trees, finding protein domains, and digging into evolutionary history.
First up, we have a true classic, the one many of us started with, Clustal Omega. It uses a strategy called the progressive method. Let's see how it works.
Clustal's approach is a pretty straightforward 3-step process. First, it does a bunch of pairwise alignments, comparing every sequence to every other sequence to see how similar they are. Then, it uses those similarity scores to build what's called a guide tree. You can think of it like a family tree that shows which sequences are most closely related. Finally, it uses that tree as a roadmap, aligning the closest relatives first, and then progressively adding in the more distant family members one by one.
So, what's the verdict on Clustal? Well, it is blazingly fast. It's an absolute workhorse, which makes it perfect when you have massive data sets and you just need an answer, like now. The downside? Because it builds the alignment step by step and never goes back to check its work, any mistakes made early on get locked in for good. That's why its accuracy is generally considered moderate.
Now, if Clustal's main weakness is that it never reconsiders its decisions, our next tool takes the complete opposite approach. Let's talk about Muscle. The name stands for Multiple Sequence Comparison by Log Expectation, and its whole philosophy is based on iteration.
Unlike Clustal, Muscle doesn't just do the alignment once. It starts by creating a quick and dirty first draft. And here's the brilliant part. It then goes back and refines that alignment over and over again. It essentially breaks the alignment apart and puts it back together, checking each time to see if the new version has a better score. It just keeps doing this until the score stops improving.
This iterative process is what gives Muscle its edge. It's generally a lot more accurate than Clustal Omega, and it's still really, really fast. This makes it a fantastic all-rounder, and honestly, it's probably the tool you'll want to reach for most of the time when you need a great balance of accuracy and speed.
Okay, on to our final contender, T-Coffee. If Muscle is the reliable all-rounder, you should think of T-Coffee as the meticulous perfectionist of the group. It uses what's called a consistency-based method to get the highest accuracy possible.
T-Coffee's whole game is about confidence. First, it doesn't just rely on one type of pairwise alignment. It actually creates an entire library of them using different methods. Then, it sifts through that library and asks, how consistently does this one residue align with that other one across all these different attempts? If a pair lines up consistently, it gets a high confidence score. The final alignment is then built using only the most high-confidence, consistent pairings.
The result of all that hard work. T-Coffee is usually the most accurate of the three. But you guessed it, that level of precision comes at a price. It is by far the slowest. This makes it the perfect choice for smaller datasets, where getting the alignment absolutely positively perfect is the #1 priority.
All right, we've met our three contenders. It's time for the final showdown. Let's put them all side by side so you know exactly which tool to grab for your next project.
This table really sums it all up, doesn't it? If you've got a massive data set and speed is your main concern, Clustal Omega and its progressive method is your go-to. For most day-to-day tasks where you need a great balance of high accuracy and solid performance, Muscle's iterative approach is almost always the right answer. But When you have a smaller set of sequences and you need the absolute highest precision possible, say for detailed structural work, then T-Coffee's consistency method is the undisputed champ.
So, if you only remember one thing from today, let it be this: Clustal for speed, Muscle for balance, and T-Coffee for precision.
And that's your bite-sized breakdown of MSA tools. Hey, let us know in the comments which one is your favorite for your own projects. And make sure you subscribe so you don't miss our next explainer, where we'll be giving you a beginner's tour of NCBI. Thanks for watching BioInfoBytes.